god, it is so hot in here.
I cannot believe we don't have AC. Like, what are we supposed to do?
Oh, wait!
Carl! Carl!
Carl will know what to do.
Doesn't Carl design AC systems, right?
Yeah, we should go to his house.
Yeah, we could let's go there and then he can help us design one.
Yeah.
Sounds good.
Hey ladies, how are you?
Hi, are you Carl?
I am.
Oh my goodness. Thank you so much. We need your help. I found your card and it's like really, really hot outside. And so I was wondering if you could maybe help us install an AC system into our house.
I can. Come on inside.
Thank you. Thank you. So, how will you help us build an AC in our house?
So, how would we do that? The first thing that we would do is we'd look at the number of people that there's energy that's coming into your house, and there's several sources for that. The first one would be the people that are in the house. Then there's the electrical equipment in the house. Then there is the solar gain and the other gains that come through your walls, and then similar thing through your windows. So we do all that. We take all that information, we put all that information together, and then we would come up with what we call a load calculation, and that calculation would help us determine what your heating demand would be and your cooling demand would be for your house, and that would help us that tell us how big it would need to be, because we basically would try and look for the peak on that graph within an acceptable bound. That determine how much energy we need to use for that and how big it needs to be. And then we'd come up with, some sort of energy graph that would explain, well, how much is this really going to cost me, and how much energy kind of over the year you're going to use.
You know what? That sounds really familiar.
Danielle, I think we learned this in Miss Spiridon's class.
Functions, right? Polynomial functions.
Yes.
Wow.
We got your load calc done, and we've looked at all those things we were talked about earlier. We're particularly looking at the solar gain that you have on your house, and you can see that it's low in the morning, and as the day kind of goes on, it gets higher and it comes back down, and it repeats every day.
A polynomial is an expression of two or more algebraic terms.
And usually it consists of several terms that each contain different powers of the same variable. So this is the equation that we started out with. Basically, to find the first x, what you would do is you would use the rational roots theorem, which is p over q, which basically is when you take the factors of this coefficient and put them over the factors of this coefficient. So it would be plus or minus 1, plus or minus 2 over plus or minus 1 and plus or minus 2. So then you just have to test all the numbers out using synthetic division. So we just tested 2. So we found that our first root was x equals 2.
And then we continued on, we got this new polynomial.
Which is basically just a quadratic equation.
Yeah. And then we did the quadratic formula, which is negative b plus or minus b squared minus 4 times ac over 2 times a. And then we plugged in the numbers and we got these two as our other zeros.
It came out to about 0.28 and negative 1.8. And so knowing that this was an x to the third, we knew that there were going to be 3 directions, 1, 2, and 3. So we just graphed it like that. And that is basically how to solve for x's for a polynomial and graph. So in his work, Carl does a lot of examples with different kinds of graphs. Some of these have to do with finding certain angles and certain points on the graph, which will determine things he'll need to know for designing the AC system. So here's this example, and it's find the angle of incident of light on a window at noon on August 1st.
So obviously this is way more difficult than what we learned this year in the first trig/pre-calc class.
And it's not exactly the same concept because Carl uses many different types of graphs and different types of polynomial graphs within his work. This happens to just be one example with using sine and cosine, however, because it finds an angle.
The window is vertical and n is the day number, which is February 3rd. This is the angle of window relative to due south, which is 0 degrees, and this is the angle of window from horizontal, which is 90 degrees. W is the hour angle, which is 0 for noon, and This later is the equation.
Basically, what he does is he plugs all those values into the equation he has, and he ends up getting 69.43 degrees, which is basically the angle of incident of light on a window at noon on August 1st.
So obviously this is way more difficult than what we learned this year in the first trig/pre-calc class.
And it's not exactly the same concept because Carl uses many different types of graphs and different types of polynomial graphs within his work. This happens just to be one example with using sine and cosine, however, because it finds an angle. All the work that Carl usually does to find these polynomial graphs is done within a computer software program.
Thank you so much, Carl.
I know, we're no longer hot anymore. It's great.
Well, I'm glad I could help you guys.
You know, in fact, we're actually pretty cool now.
Yo, VIP.